we were discussing primarily the monocouple systems, and we have seen that how like waves are propagating once the one unit is connecting to the another unit with a single link. Now if you think, there is another very interesting way of connection we can able to think. Like suppose we have these masses, and so this is like our monocouple chain, monoatomic monocouple chain, like they are very nicely connected, one unit with another unit. So here the connections are all with its near, just neighbor. So like if you see, like this guy is connected with its neighbor, again is connected with his neighbor. This guy also connected with this neighbor, So here the connections are, connections are only between neighbors, only between neighbors. There is no other connections are existing. So what to do? So in that case, but now can it be possible that there is some non-local connections exist, or like or non-neighboring connection? Like for example, let's say, can we have a connection like this and this? Then what will happen? Or maybe some sort of tertiary level connection, like for example, this is connecting with this is connecting with this, a tertiary level of connection. So if this type of connections are started arising, then they are no longer just remain a monoatomic chain, then this was converted into the connections beyond nearest neighbor. Connection beyond nearest neighbor. So here we are connecting beyond the nearest neighbors. So they are actually, the dispersion phenomena is very, very different compared to the normal behavior. So let's try to first see that how can we able to write the equation of motion for the nth mass of that type of system. So let's say we try to write the equation of motion for this mass. So let's say this is my nth mass. So nth mass can be written like this, plus, so that is my inertia term, plus k j into 2u, means kn into 2un minus j un plus j. That way this connection will come, k j equal to 1 to n. So here if you think, what is the j is actually doing? So j is actually doing, like suppose if we do not have any beyond nearest neighbor network, then what will happen? Then we can simply write m into un double dot plus k1 into 2un minus un minus 1 minus un minus un plus 1. And now, so that is my k1. That's the k1 stiffness. Now what is K2 stiffness? K2 stiffness is basically the stiffness for the second, the tertiary order of connection, that is K2. So what happened? Now next we are doing like K2 into 2un minus un minus 2 un plus 2. That connection is coming from K2. Now what will be K3? Now K3, if you think, that is primarily my K3. So that is K3 into 2un minus un minus 3 minus un plus 3. That all equal to 0. So like this way, whatever the number of connections are coming, those terms will be coming into picture. And that's quite interestingly we can able to get our equation of motion. So now here there is a very interesting points actually comes into picture, because now implementing the Bloch theorem becomes quite challenging, because previously what happened, previously once we are implementing the Bloch theorem, we used to just say that okay, we are having un plus 1 equal to un into e to the power of I mu, and un minus 1 equal to un e to the power of minus I mu. Simple, we just put it. But here that thing will be little bit difficult, because now you have un plus 2, un minus 2, un plus 3, un minus 3. So all the, like whatever the j is coming, whatever the order of the like connections are existing, that level of Bloch theorem has to be implemented in the same equation of motion. That's quite challenging and quite different also what we have done till to date. So here we can write, therefore this type of simplified Bloch theorem writing will not be working here. So what can we do? We can write it the generalized version of the Bloch theorem. So like we can write it u of j in plus j will be equal to un into e to the power of I times mu j plus omega t. That we can write it. Okay, so that is basically the similar thing, not that difficult. So that way we can write the full matrix, and then what can we do? Now if we start substituting it, what can I get? So if I just start substituting this full thing into this equation, I can get minus m omega square un plus summation of j equal to 1 to n kj into 2 minus e to the power of I j mu minus e to the power of minus I j mu, and that should be equal to 0. U should be, yeah, so un we can think like it's like multiplied with un, and that is equal to 0. So this thing is equal to 0. So now what is my dispersion relation? So now dispersion relation comes m omega square plus summation of j equal to 1 to n kj. 2 can go, and 1 minus cos j mu, and that should be equal to 0. Interesting. So now if so, up to that stage, any doubt? Can we write this? Simple. Means we just put it, we got it. Now where is the difference? In the previous cases, once we have solved, we see that this portion was quite simplified. It was normally 1 minus cos mu only. Now here what happened? It is like cos 1 mu, 2 mu, 3 mu, like this way the whole thing is coming. So like if I just try to expand it, okay, so if we see that minus m omega square plus 2 kj, and this is equal to 0, that we can able to get it as like a solution. So how, if we try to look at more detail how it is coming actually, so this portion is nothing but like 2 into k1 into 1 minus cos mu plus 2 into k2 into 1 minus cos 2 mu plus 2 into k2 into 1 minus cos 3 mu, like this is equal to 0. That's something like a matter. So now if we try to calculate the omega, like we have seen that there are the two ways how we can able to solve that full thing. So first one is, so this is my dispersion relation. Any doubt on that? I think no doubt. Okay. So dispersion relationship, this is the dispersion relation. So now if this is the dispersion relation, so this we know that we can able to solve it into the two ways. One like driven wave, and another is the free wave. What is the input for the driven wave? Input for the driven wave is omega, and output is mu. So what is the input for the driven free wave? Input is mu. What is the output? Omega. Now tell me which one is easier from here? Driven wave or free wave? I think very clear cut thought, that is the free waves. Why? Because input is mu. So what basically we are solving? If I try to solve it into the free wave, I am basically solving m omega square should be equal to 2 times kg into 1 minus cos j mu. Okay, j equal to 1 to n. So omega square equal to 2 by m summation of j equal to 1 to n kg into 1 minus cos j mu. Done. Done. That's a very simple way how we can able to get it. So I can able to input the mu and I can try to get whatever the omega is coming. How many value of omega I can get? Now if you think 1 minus cos j mu can be written as sin square j mu by 2. Okay, so that way also we can able to rewrite that full thing. Okay, so this way the full thing can be written. So we can get omega in terms of mu in a very simple manner, because if you see all the terms we know, like m is the mass of the chain, kj is different level the stiffnesses, so that is also known. Mu we are inputting, known. This is cos, so cos is also known. J is like varying from 1 to n, so these all are known. So we can easily calculate whatever is the omega, and omega will be like omega plus and omega minus. So it's okay, we don't need to take the minus, we can just forget the minus out. So forget it, minus. So we are just having like a positive value. If we are taking, then we can able to get the graph like this, and we can go up to 0 to pi. But here there will be a catch. So this is like a normal monoatomic chain. If you take, you will get the graph like this. But here we can found some interesting phenomena. That wave thing will be sometime like this. This type of variation we can start able to see here. That is quite interesting. Here we may able to get the negative and positive group velocity simultaneously present in a single band. That's something like a very interesting. Like this thing happened. Now if you think, like let's say, so like this type of curved thing we can able to see. Now interestingly, if we check a wave in that band, what will happen? Now what is group velocity? Group velocity is basically del omega over del mu. So these slopes. So what we can see, that in this portion is like positive, this portion is negative, again we have positive, again some portion is negative. That the group velocity is going like this way, and this full thing is present within a single excitation frequency band, and that's a very interesting phenomenon. Because think how the wave will going to propagate in that medium. Does the group velocity positive? Will that the group velocity be negative? What will be the group velocities for that full thing? Because group velocity is one of the prime point by which we can able to think that how, like if we give a packet, how much the energy is propagating, what is the speed of that energy flow, all those things will be coming from the group velocity. Does that peak will reach to its position properly or not? All those things we can able to see due to that group velocity, from that group velocity. So here we can see a coexistence of the positive and negative group velocity in a same band of frequencies, we can able to notice here, and that's a very very interesting phenomena altogether. So this phenomena is often called as roton like phenomena. So here coexistence of the negative and positive group velocities can be seen.